Number 11 looks like one where maybe we would factor top and bottom. Right, direct substitution doesn't work. So we talked about factoring before. Well, this one doesn't factor nice on top. So instead of doing that, what we need to try is synthetic division. I know you're groaning, but yes, we're going to use synthetic division. For this, just a refresher, we're dividing by x minus 1, so we're going to have a positive 1 out in front. Then we're going to use the leading coefficients inside, so we have 1x cubed, negative 4x squared, 5, and negative 2. Doesn't happen here, but remember, if there's like a missing space, let's say we didn't have an x term, we'd have to put a 0 in its place. Then we're going to go ahead and bring down the 1. 1 times 1 is 1. Add these, we get negative 3. 1 times negative 3, we get negative 3. 5 plus negative 3 is 2. 1 times 2 is 2. Add these, we get 0. So there's no remainder. We started off with a function on top that was cubic to the third degree. So when we divide by an x, it's going to end up giving us this whole part that's quadratic. So it's 1x squared minus 3x plus 2. So this can be factored. Actually, we don't need to factor it in this case. This is basically what we end up with. Right? X squared minus 3x plus 2 times x minus 1. That gives us this. Right? Just like some problems we did before, when we have a common factor top and bottom, that creates a whole. So now all we're doing is looking at the limit as x approaches 1 of x squared minus 3x plus 2. Because it's going to be the same as this. The only difference is there's going to be a whole when x is 1. So we put 1 in there. 1 squared minus 3 times 1 plus 2. And we get 0.